Thank you.
So yesterday class were helpful.
Very much.
Okay. So let's have a discussion on the yesterday class. Let me know if you have any queries. We can try to resolve it now. Any silly queries, any silly doubt, whatever it is.
Um, we covered mostly CPD yesterday.
Mm-hmm.
Most of it, trying to see how the SIG communication works. We tried to see if we can see the failed, but we weren't. But that's just part of debugging. And then we saw the two levels of user mode and kernel mode. So I think I'm at this level. I'm okay. I got it. So
So if I ask both of you if kernel mode want to signal to the user mode how it does,
it will send a trap, and
yeah, right. And how about the user mode want to signal to the kernel mode?
it will send a IO. What do you call that thing? IO.
I control.
Yes. Input output controls.
Mhm.
Okay. What are the processes reside in user mode
The,
or
um,
daemons resides in the
the,
user mode?
I think most of all.
Yes. So the core which we saw CPD, FWM, FWD, right?
Yeah.
Today we will not start with or we are not continue with the same thing. We'll go to the new concept, and once this concept is finished, we'll come back to the previous thing. Okay, so that it should be not look for bore. That was the purpose. It will be not disconnected because we have a good understanding on the demands now. That's why I'm just moving to the new topic, and again we'll come back to this original topic. Okay, and today is more of interaction sort of things. So let me know if you guys able to see my screen.
yes.
All right, great. Let me minimize this. Right. So have you, as we are on checkpoint wall, we should know what is core Excel. So I want to hear you from you guys. What is core Excel? What do you understand about the core Excel? Any thought coming in mind when I say core Excel? It
Something to do
might be
with
not
CPU.
correct. Yeah, go for
Something
it.
to do with something to do with CPU cores,
Okay.
and maybe assigning different traffic to different cores. Maybe that's just my guess.
Okay. So you said something to do with the CPU core.
Yep.
Okay.
And prioritizing traffic through those cores, maybe. Must.
You know what is the difference between the core and instances?
No.
Okay. Core we also call CPU, right?
Hmm.
I'm not talking about the central processing unit. I'm talking about uh, the processor which was having a motherboard, and with that they were having some chips, and that chip come up with the different cores, right?
Hmm.
And that cores uh, is basically nothing but your firewall, or sorry, nothing but your that CPU's kernel, we can call instances, right?
Hmm.
Okay. So now tell me, having more cores with your processor is good or no?
Yes, we can do more work,
It will do more work.
assign different jobs to different cores, maybe.
Exactly. So assigning different jobs to different core. What happen if we do this, assigning different jobs to different core?
Balance the workload,
Okay. One is balance the workload.
prioritize some of the traffic,
Perfect. Prioritize traffic. What else?
mm,
What the core will do?
mm, what else can I do?
Does it increase your throughput?
Yeah.
Right?
Hmm.
Better performance.
Yeah.
What else?
More calculations, more. Um,
More calculations, of course. So having this feature in place is best or no?
yeah, it's best.
Is of course best, right?
Mm.
So this is what we are going to learn. See, the concept, the name is core Excel, but whatever we are learning on this is very general. So always think in this perspective. This is not a complicated things. People make it like very complicated. There are two things. One is core Excel, and the other one is secure Excel. Okay,
Hmm.
we'll talk on this secure Excel in a continue part of this core Excel. But for now, just concentrate on core Excel. Okay. So let me take this out and let's go back to the slide. So I just wanted to ask, is it okay we divert into the core Excel from that
Definitely
previous class?
okay for me. But
Because
no.
we are fresh
Yeah.
and learning the concept will be great. And once the concept is clear, we'll come back to the lab again, and we'll
It's
deliver the same work. Is
no
it okay
problem.
with you, Ruturaj?
Yeah, not an issue.
Okay.
So, are we going with discuss
Mm-hmm.
later on the other demons also?
Yes.
Okay.
So we only have covered the CPD. So rest of the demons will be discussed. But why I choose this part? Because it will be feel bored because we already know how to do the troubleshooting and everything.
Mhm.
That's why. Okay. And it's
Okay.
a
Okay.
fresh morning. Let's have some tough topics. Okay. All right. So I'm happy that we know the core Excel, right? Okay. Now, before core Excel, how the world was, you know, let's discuss how a packet is being processed from the CPU before introduction of the core Excel, right? Now imagine the packet is coming in, it's coming into the CPU. For example, this is your NIC here, Okay, and this is what the firewall you have, and your firewall was not having the feature of core access. Okay, so now the packet will from the outside world, inside world, okay, will come to your CPU, and now CPU is going to process that packet or that connection, whatsoever is initiating towards that firewall. Okay, what happens here before the core Excel? What was happening? You know, uh, the first thing uh, the firewall does, it executes this code. Okay, whenever the packet comes to your firewall, firewall lock their processing. So, for example, consider the packet comes on the CPU here. This is a packet. This packet CPU one, lock his processing. So whatever the processing is happening now on this packet, same time consider the another packet reach, okay, to the firewall. Say there's a packet number two. This is packet number one. This packet number two has to wait until the packet number one's task is get finished by the CPU. So firewall is at the lock stage now. The packet two comes, you know, it sees that okay, the packet one is still processing. Once the processing is done, then next, uh, the processing is done. The next, the firewall unlock his code and it allowing the second packet to process here. You know, having such sort of arrangement was, giving you less throughput, less performance, everything less, whatever it is. So whenever consider this is I'm talking about the one CPU. Let me clear the screen. Having the another CPU also will not help much here. Consider CPU 2. Again, the packet will come to the CPU 2 and 1, and these two packet need to be processed first, and this CPU need to be allocate their time, their whatever the processing or code, they should lock that, and until that processing is done, it should not get a new packet. This is how usually happens in an operating system when we talk about the single processing, right? This is what happening before the core Excel was introduced into the checkpoint world. This was a simple code they were running, you know, whatever the packets coming to the firewall, lock themselves. Then it was doing the processing in that packet and then unlock themselves. So the next packet will come and process. You know, that was the fundamental. Later on, they realized that this is not work. This will not work because the throughput, because of the you know rest of the criteria, considering the things. So this approach was not helpful. So they introduced the new feature, uh, which they call this thing, the firewall kernel instances. Okay. Now, uh, let's talk about how this approach helped them, to resolve some sort of, uh, the bandwidth constraint or processing constraint. So whenever the packet comes hit to the, you know, uh, your firewall, for example, this is your firewall and this is your NIC. Okay. Whenever packet from this NIC reach to the CPU, CPU one performing the tasks. and the CPU 2 also, for example, performing the task. But having two firewall code or kernel instances in place, uh, which were running the same policy. So in one firewall, we have multiple policy packages, but when we assign a particular policy to a particular kernel instances, okay, that time we can call it as okay, that kernel instances are running the same policies. So having this arrangement, having a two kernel instances or a firewall code in place and running the simultaneously the same policy was help, you know, to process this packet whichever reaching to these CPUs, and having this code impose their functionality on those packets, was increase the throughput somehow. But again, uh, this sort of approach were not that great to handle the things, because there was no intelligence which decides which CPU take packet. For example, uh, give me one second, guys. So for example, uh, from the NIC, the packet is coming to the CPU 1, and if the next packet also reaching to the CPU 1, okay, having the CPU 2's bandwidth free, okay, will not understood by the firewall whether the CPU 0 having the the bandwidth and the CPU 1 is processing the packet. So that intelligence was not there. you know for that, again, they introduced the concept called dispatcher. So there is something called core Excel dispatcher. you know so this dispatcher, we call it, say for now, as a D, was doing a work of assigning the whatever the packet coming out of this NIC. So the packet coming out of the NIC will reach to the dispatcher, and this dispatcher going to decide where that packet need to forward. For CPU 1 have a bandwidth, the packet will be forwarded to the CPU 0, and CPU 1 having the bandwidth, the next packet will forward to the CPU 1, provided the connection should be sticky. What that means, for example, same sequence number packet, the same communication packet has to be forwarded to the same CPU, which help to avoid the situation in which we get from the asymmetric routing sort of things. So this sort of work is delivered by these dispatchers. You know, and this dispatcher also consume your one of the CPU. So one of the CPU, you can make it like a dispatcher, and the packet whichever hitting to the CPU, the CPU role is only that to send those packets to a relevant CPU which were having the bandwidth. That was what uh, that was happening you know with this kernel instances, and having this multiple firewall code you know was helpful to process this packet fastly. Why? Because introduction of this kernel instances, I mean this firewall code, we also call it kernel instances. Okay, so these are the two instances for now what we have. Having the different feature with these instances were using for the packet processing. So how? let's discuss that. Number one thing, it has their own memory and the cache, and the the thing which they keep the connection details into their connection table. So those intelligence were having with this kernel instances. So whichever the packet processed by these kernel instances, their details like a source IP, destination IP, source port, destination port, protocols, those details were captured into these kernel instances. And based on the match of the packets which having the details stored into this kernel instances were processed fastly. So that was the role of this, kernel instances, and having a multiple kernel instances assigned to the multiple, packets were, giving you a better throughput in terms of this intelligence, what they were having. Okay. And this dispatcher also have their own memory cache, and we call it as a connection table. Okay. And keeping those details in their connection table also helps to process those packets uh, fastly, providing you the more throughput and everything like that. So this was the basics of the core Excel. Okay, I'm sure you guys never heard about such thing, because nobody explains this thing in this way. So let's stop here and let me know if you have any doubt here.
Maybe you have a question.
Yeah.
Okay, the question I have is this FW0 and FW1, is that after the CPU or before the CPU?
It's see, I'll tell you. Consider this is CPU is your core. Okay, that's why I ask you what is the core and what is the firewall kernel instances,
Mm-hmm.
right? So core is the part of the CPU. So consider this is your processor, okay, and this processor is divided with some cores, right? And based on
Mm-hmm.
that cores, we measure this performance, right?
Okay.
So these CPUs are nothing but the cores, okay,
Yeah.
and these are the instances of those cores. So
Oh, okay.
yeah, so this thing comes first, right? And out of this we can derive these instances. It's not our task to do that. It's firewall intelligence which provide you those details, those things, right? But this is what it is. Clear?
Yeah. So the dispatcher will send the data to the instances.
Yes.
Okay, that's it.
Any other thing in mind?
And you said one CPU core is dedicated to the dispatcher.
Yes.
Okay. And then the rest is for each instance. So,
Right.
and you can have as many instances as possible, or is it dependent on how many cores you have?
So this picture will help you to solve your query.
Okay.
So
This is how.
each CPU will have a default uh, FW code or instance.
So you when we look into the more into the command line, have you run the top command so far?
Yeah.
Yes.
Mhm. Have you observed the one thing, AW Walker there?
Yeah.
This thing. Have you ever come to know what is this AW Walker?
Mm, that's what maybe instance.
Perfect. So that is the instance.
Mm.
So, you know, two things we'll observe. One thing you will see CPU 0, CPU 1, CPU 2, and one thing you will observe AW Walker. Okay, now clear the difference. So this FW Walker is your firewall kernel instances, and these are your CPU is nothing but your code.
Got it.
Clear, Rutraj?
Yeah.
Awesome. Give me one sec. Now this picture will help you to give you more clarity, right? So how the parallel processing happens? So as I said, one CPU, say CPU 0, is given as a dispatcher, but again I am saying for now it's a CPU 0 which act like a dispatcher, or one CPU given as a dispatcher. But as soon as we increase the core, okay, we have a flexibility and a facility to increase the dispatchers. So consider only one dispatcher delivering your work. For example, CPU 0, all the packets are from the NIC is reaching to the CPU 0. Okay, and from here he only processing all these things, sending packet here. It has their own connection table, keeping those connection into this. But you know of course there is a limitation for this, you know how much traffic it handled by one dispatcher. It's also there is a limitation, right? So in practicality world, depending on the different uh, core, how many cores you have, you will be having a multiple dispatcher. Okay, so CPU say 4 is again a dispatcher, CPU 5 again a dispatcher, you know. So all the packet will coming out of the NIC will go to the different dispatcher, and different dispatcher will handle or send the packet to the different firewall instances, and this having the connection table within them. So whatever the packets coming to them, there will be a multi or parallel processing happening on that. I mean, the based on the match on the connection table, the packets are getting matched, and the work is getting delivered. And having this sort of arrangement will also helps to avoid the asymmetric things. As I said, the connections are sticky. Okay, what that means? So one packet is reached to the CPU 0, okay, and second packet will reach to the CPU say 4. Now the same packet is processing by the CPU 1, or sorry, this firewall instance 2. It should it should not, it must go to the firewall 2 kernel itself, okay, because if the packet, suppose this is a packet 2 is coming here, and packet two's part is coming here, okay, but this work is delivering by this instance, okay. So CPU 2 is supposed to forward a packet here, and this guy also supposed to forward that packet here. But this thing in a practical world it not happen like that. Whatever the packets, you know uh, say CPU 0 will come, say it has a one sequence, say some TCP three-way handshake packets. Okay, if he has forwarded that packet to CPU one, subsequent packet will be forwarded to the CPU one. Okay, it will not forward the similar packet to the firewall one or here. Okay, the connection is always sticky. You got my point, or I can rephrase it because the simple point is, but need to be understood. Connection require to be sticky. What do you mean by sticky in a checkpoint world? So whatever the packets, processing by the firewall kernel instances, if the packet having the communication initiated for some purpose, that packet need to be handled by the one instances. In a simple world, let's understand. This is your say client, this is your server, and we are doing the three-way handshake. So the client initiated the packet communication to the server, say he want to access some FTP server here. Okay. So initially what happens? The three-way handshake, SYN, SYNAC, ACK, data transfer, right? So all these four packet, for example, the first packet out of this will hit to the CPU 0, CPU 1, then packet 1, 2, 3, 4. So all 1, packet 2, packet 3, packet 4 must be handled by this CPU 0. So this is what we call it keeping the connection sticky. And that work is delivered by this dispatcher as well. Clear now or any doubt here?
That's clear. Thanks.
Okay. Ruturaj?
Yeah.
Okay, great.
Yeah.
So the stickiness must be there not only in this world, in any world what we're talking about to avoid the asymmetric things. The time the packet not be sticky, what will happen? Say the number one packet processed by the CPU1, the number one packet goes to the CPU2. Do you think CPU1 will have the connection table having the number one packet details stored here? And based on this connection detail, it will allow the second packet or whatever the packet pushing happen on the second packet. But again, if the dispatcher send that second packet to this CPU2, this connection table will be not having any detail on that packet. What will happen? That packet get reject, right? To avoid such situation, the connection must be sticky. Okay, that is the case. And what are the packet coming? It will process parallelly, having a different dispatcher in place, like that. In the last picture, uh, you'll be seeing that in a real world, that having a multiple dispatcher and everything, right? Next. So I'm sure you guys have heard about these terms, but I'm sure you maybe not having the meaning with you. Have you guys heard about these terms so far? Let me know. You have any idea on these terms?
I've heard of connection table, but nothing else.
Okay, don't look into those notes. Those are not correct. I'm just deleting it. Uh, how about you, Ritiraj? You heard about this term? SIM affinity, CPU affinity, multi-queue in Core Excel?
Yeah, just heard about the same affinity. I'm not remembering that those things. Not in
Yes.
my mind right now. But some assigning the interfaces to those CPUs.
Okay. What that mean? CPU affinity, SIM affinity, or multi-queue affinity?
It's kind of you can just distributing your dispatchers with the course, or that kind of. Maybe I'm wrong.
So your direction was right. Maybe you heard it somewhere while learning. So these are the terms we will seeing during the command line. You know, that's why I have this slide here. So let's talk about the CPU affinity. So, you know, we have the ability to allocate different processes to different CPUs. Okay, so say whatever the packet is coming from this NIC, okay, it will reach to your dispatcher, and this dispatcher will say, okay, the let's forward this packet to this CPU1, and this CPU1, you will make it like that. It will handle the packets, say for, say what are the packets coming out of the FWD process only. Okay, you have those procedure. So consider the FWD process manages all the logging things. So all the logging packet will be handled only by the CPU1, right? That is what we call as a CPU affinity. Any doubt here? No?
No, we
Next.
got
Great. Next is SIM affinity. So binding a port to a particular CPU and rest of the port to the different CPUs. So for example, your firewall having a multiple ports, okay? Say port 3, 4, this is 2, 1. So for example, I have bind this port to CPU1, okay? So whichever the packet coming from this port, say this is your DMZ, okay? The DMZ interface is attached to this port, and your all web servers, you know, having data behind this NIC, you know. So, in the real practicality world, what we do, having, for example, I have the Amazon side, okay, Amazon web servers, and Amazon want their prime customers to come from this particular, interface, and get this much throughput and get this much, data, because they are prime customer, they are paying more, so give them a more facility. I'm just giving an example. So for such situation, you can allocate a different, instances CPUs to a NIC. Okay, so one NIC will be having a one port, or one NIC will be having, uh, multiple ports, depends. So like that arrangement, we call it SIM affinity. Any doubt
but
here?
it still has to go through the dispatcher and then get to the CPU, which is dedicated.
Dispatcher also is a kind of CPU, right?
Uh huh.
So you can allocate this dispatcher here. Okay.
Oh,
So
got it.
with the NIC, you will be having a dispatcher. With the NIC, you will be having the CPUs.
Got
Okay.
it.
It's very in depth. How you want to expand, you can expand it. But the concept need to be there. So when I talk about the CPU affinity, you should know I'm talking about the process allocation to the port. When I talk about the SIM affinity, you should know I'm talking about the port allocation to the CPUs.
Got it.
Clear?
Yep.
Now, multi-queue, the last concept over here. So, consider some firewalls with, like a checkpoint firewalls, they come up with some limited ports, and maybe you have a situation where you'll be having some limited ports with you, and you have to play on that ports only. you know in that situation, what you can do, you can use this feature called multi-queue. Okay, and within a small number of your interfaces, you can assign a different interfaces. So there is something called IRQ, uh, uh, which is like a interrupt queue, which you can use to assign, with the different your ports. Say you have two ports only, so one port will be having multiple IRQ interrupts, and one will be having a multiple IRQ interrupts. Same with the CPU. You know, you do the arrangement and do the configuration so that just two ports having flexibility to achieve the multiple CPUs work. So one port will have a multiple CPUs using a feature called IRQ. Okay, let's not go more depth into this, but just understand the concept. What is the multi-queue? All right. Any doubts so far? So tomorrow,
Multi-queue is a
yeah.
bit confusing, but that's fine because we're not going more deeper
No,
into it.
I mean, I don't mean that. Don't go into that deep. I'm talking about the configuration perspective. But
Oh,
concept-wise, I wanted you to understand when you have a limited number of ports. Okay, say your all other ports are occupied for some other work, and your two ports only. You're thinking about get more work done from them. So in this port, you can enable some feature called IRQ, interrupts queuing.
got
Okay.
okay,
So interrupts queuing is also having some sort of a mechanism where different the CPU will be taken care of by these different interrupt queues, you know,
yeah,
like that.
got it.
So that is what comes under the multi queue,
Okay, that was clear.
right? So tomorrow, if someone asks you what is CPU affinity, SIM affinity, multi-queue, you're going to answer it now?
Yes.
Awesome. Now, next concept. So when we talk about the allocation of the core XL, so core XL, the number of the kernel instances is based on the total number of core in the system, right? This slide explains how many dispatcher you need to have when you have how many cores. Okay, so for instance, you only having the one core, by default the secure excel will not work because there is no dispatcher available for that. Okay,
Mhm.
you won't be able to create any kernel instances, it won't work, so this condition is failed. Having the two cores, you know you can make that two core having two dispatchers. Okay, dispatcher is what? Is nothing but your CPU, right? But it also have the ability to process that packet. You know, so when I talk the first example, there was a two CPU, right? But there was no dispatcher with the neck, so only two CPUs were there. That time, the packet will come here. This packet will process from here. The next packet will come here or here. There is no intelligence. Okay, but again, this can be the dispatcher, right? Because they are doing their work, right? Handling the packet itself. So having two core, you will be having two dispatcher. If you have the four cores, you can make it like a three uh, core kernel instances as a dispatcher and one as your firewall code, and you can achieve the functionality of the similar sort of things. Like that, if you have the 8 cores, you can have the 6 dispatcher in that. You know, that is the limitation what you have. So if you have 8 cores, out of that 8 cores, you can make 6 core as a dispatcher. Okay, and if you have more than 8 cores, you can have the feasibility of like for example, you have a 10 core minus 4 equal to 6. We can make it like a 6 dispatcher. If you have a 15 core minus 4 equal to 11 core, you make those 11 core as a dispatcher. Okay, this is what this slide explains. Any doubt here?
Yeah, I'm good.
Suppose we have the 8 cores, and as you're saying that we can make max 6 dispatcher.
Mhm.
So is that the limitation? We can go with that dispatcher,
Yes, yes. This is come from the
but is
checkpoint.
that work? Is that work?
It's that
Means
work. I mean,
if we go with this, if we have the 8 cores and if we go with the 6 dispatchers,
uh,
and rest of two will act as instances.
no. What I'm saying, it's a limitation from the checkpoint. So you can make 8 out of 8 core, only 2 dispatcher. Okay,
Okay.
and 6 as your main core, firewall core, who's processing the traffic, for example, right?
Mm-hmm.
But in practicality, if you
Mm-hmm.
want to make that 8 core as 8 dispatcher, it will not work. You only have the flexibility to, out of 8, you will only make a 6 as a dispatcher. So tomorrow you will ask me, okay, just out of 8, make 7 as a dispatcher. This 7 need to be dispatcher. You can't do
Mm.
that. You only having the facility
Six
to
one.
make 6. That is what this slide explains.
Okay.
Clear?
Okay. Okay.
Okay, great. So I hope we are good in terms of the core Excel concepts. Let me ask you, have you ever reconfigure the core Excel of your firewall,
No.
No.
right? Uh, Reinstalling the gateway will change the number of the kernel instance if you have upgraded the hardware to the increased processing cores or the number of the kernel instance was changed. Use cpconfig to reconfigure the number of the kernel instances. So when you run the cpconfig command, you will see one of the option to reconfigure the kernel instances. Okay, we'll be seeing that in a bit. We will run the cpconfig, and with that we will see how we can reconfigure this kernel instances. If we have a multiple instances in place, multiple core in place, it will be more easy to understand the concepts. But nevertheless, the concept is important than the configuring. We'll see both. Okay, now let's talk about the secure excel. So guys, tell me what is secure excel. I just wanted to hear, don't look into this slide, just tell me what is secure excel. Any idea?
I think it has something to do with traffic flow, some kind of prioritizing the traffic.
If we prioritize the traffic, we'll use the concept like core excel, right? That is what we have seen. The
Mm,
dispatcher.
maybe VPN traffic. No, I
Which
don't
one?
know. VPN traffic.
Even the VPN traffic also take care by the core. You know,
Oh, okay. So then
why
I
you
have no.
want the new technology in place out of that.
Yeah, I have no clue what Secure Excel is.
How about you, Ruturaj?
Just heard about that. It uses for performance to maximize the performance.
But how? That was I'm asking.
How to offloading load to the third party software. Third party means it's kind of software.
Mm, see, not like that. The software is checkpoint only. Okay, but your concept was okay, okay. So, but not correct. So let me go to the slide.
Mm.
So, Secure Excel is nothing but a security acceleration or accelerating your packets. When I say accelerating, what it means, the the flow of that packet, you know, or the speed of the processing of that packet, you know, that get expanded. You know what is stateful packet inspection? Uh, we have discussed in our previous classes, not on this platform, but the CCSA classes. Have you heard about what is stateful packet inspection? This
Packet,
class will be interactive, guys. So just let me know what is stateful packet inspection.
the packet leaving is recorded, and so when it comes back, it knows that it left from this port, and so it doesn't need two policies, just one policy.
But what actually does?
It keeps a connection table.
What connection table have?
The source destination port number
Right.
of
So
incoming and then up.
in Secure Excel world also, the Secure Excel accelerate firewall and VPN performance by remembering certain attributes of the packets and the packet flow that have already been validated by the firewall VPN applications. Then validation of related packets and the connection is delegated to the Secure Excel API. Secure Excel having their own connection tables. If you heard about the stateful packet inspection feature, what the firewall do over here, whatever the packet coming to the firewall, it capture those packets details in a kernel table, like a source IP, destination IP, source port, destination port, protocols. And based on those captured details, whatever the subsequent packet will come to the firewall, that packet will accept, right? It don't have to recapture those details because of the feature what we have the stateful packet inspection, right? Likewise, there is something called Secure Excel API application interface or the algorithm which they have used, and this is not a third party. Uh, Ruturaj, it's a patented technology from the checkpoint itself. So they have this patent called Secure Excel, which is used for all this purpose. So this validation is done at the hardware interrupt level or supervised execution of the further optimized code, attached to this particular network, uh, security appliances or a soft piece. Uh, Having this sort of arrangement in place, what happens, you know, your computing overhead, which generally required by the firewall for processing all the packet through all the layers, uh, that get reduced, right? Okay, I'm sure you guys are a little bit confused, so let me give you an example. So consider this is your firewall. Okay, this firewall is having only stateful inspection enabled, but no secure Excel. And this firewall having stateful inspection and secure Excel. Remember. So let the packet come here. What will happen? That packet goes to no secure Excel, so it will not go here. It will go to the stateful inspection. Here the packet details get stored, you know, and then the packet, subsequent packet will come. It will, again process go here, and based on this, that packet get processed further. Okay. When the secure Excel is enabled, same packet will become here, you know, that data get loaded here, and subsequent packet whichever coming here, those will match this data only, and it will process. Okay, there is no need to reach here. This is an additional security. Okay, in case this guy is not able to handle that traffic, that packet will go here and process from here. Okay, but guys, this is not it. I just wanted you to understand what is secure Excel, in a very ground level. This is not a percent one of the secure Excel, but a concept what I want to give. So it has secure Excel has their own connection table, template table, and like here we have a stateful inspection table. In a secure Excel, we used to have a connection table or a template table for all this processing. Okay. So far, at least the basic is clear.
What decides what goes into a secure Excel table and what goes into a, is that maybe later down the road, or so who decides what goes into a secure Excel table compared to that
Right,
stateful inspection?
right. So it is in line. Okay.
Mhm.
So next slide talks about that.
Oh, okay.
So let me go to the next slide. Now see your mind is working. The approach, you know. So let me go to this slide. Okay, let me get paint simultaneously here. It's okay. So let me minimize this. So when we talk about the secure Excel, you know, there are multiple parts. Okay. So they have accelerated path, they have medium path, they have firewall path or a slow path. But before reaching here, let's understand what is this path. Okay. So consider this thing. That's why we call it core Excel and secure Excel, they work together. So consider this is your firewall. Okay. Here you have say ETH0, ETH1, and here say ETH0 again, ETH1, because we are talking about the same reference. Then you have here say your CPUs, so call it like a core 0, core 1. Okay, in the core Excel what we have learned, we have here dispatcher, right? We have a dispatcher, okay, and then at the top we have your firewall kernel models, right? And it has having their own connection table or something like that. And here they will be running on different CPUs, say 2, CPU 3. Okay. Now this is what the core Excel will provide you, all the flexibility. But when I enable a secure Excel in checkpoint world, there's something called performance pack. PPAC, it also called secure Excel, right? When I enable it, it's lie on this part of your CPU, right? Now, so when I combine my dispatcher with the performance pack secure Excel, okay, the new things come into the place which they call SND. SND stand for secure network dispatcher, okay. And to answer to your question, who take care of this thing? This packet processing take care by the secure network dispatcher. And what is secure network dispatcher? Is a combination of your core Excel dispatcher and your secure Excel feature. And it was, or it is having its own memory. It has its own cache, it has own tables. One is your connection table, one is your template table, right? So now the packet comes from the firewall, okay. The first packet, we call it, consider we're talking about the slow path, okay. So the packet comes to your firewall, and when it goes from all these various stages, say this performance pack, core Excel, dispatcher, then your firewall kernel, process that and to the outside world, again, TCP/IP stack. This we call it like a slow path. I mean, the packet is reaching to all the stages of your firewall. Clear?
Mhm.
And now the subsequent packet comes, or the if you have some packet which is already existed. For example, consider the same packet which is reaching to this path. Now this data is stored by or captured by your performance pack, right? So it has your own connection table memory here, this secure Excel thing. So this detail of this packet, which was processed by all the stages, it got captured here, right? So the subsequent packet which will come now, it will only process by this table. It don't have to go from rest of the processing, right? Which is like this. This path which take by the firewall, we call it like accelerated path. Clear?
because because there's already data or the records from the earlier route.
Right. So all this data, but where it got captured? Secure Excel performance pack. It don't have to get captured. I have explained every model have their own table and the memory and cache, right?
Mhm.
Everywhere, but it not has to go here. Don't has to go here. From here itself, it processing that thing. Just imagine what level of the throughput increasement we will get out of this sort of arrangement. That's why we enable this into our firewall. You know. Now, uh, are we clear on both the path? Any doubt here?
Okay.
Uh, Ruturaj?
Yeah, as you said, and in earlier slide also, that dispatcher also has the connection table, right?
Yes.
And now with the secure Excel, Excel is also have maintaining the table.
So what happens here when we enable this thing? Okay, dispatcher. When we enable this path like a secure Excel, this technology combined together, and now this combined technology, we call it secure network dispatcher. Only having a core Excel in place, excuse me, consider uh, you have not enabled this core Excel, secure Excel. Okay, just forget about this part.
Hmm.
Okay,
Hmm.
now only what you will have, you have a dispatcher, right? And dispatcher having its own kernel table, right?
Yep.
So whatever the packet will come here will process by this thing. Okay, but obviously some strength which is added via having this acceleration in place will be not there. So when we enable the secure Excel, this dispatcher strength and the
Mhm.
secure Excel strength that get combined together, and one thing come out of it, which is SND, secure network dispatcher. Okay, and
Mhm.
now when I
Mhm.
talk about this thing, don't think about it will also store something and this guy also store something. Only this guy is act like a one unit,
Mhm.
and it will store the details.
Okay.
Clear?
Yeah.
Okay. So are we clear on slow path and accelerator path? Right? Now on this mess only, I want to talk about the medium path. Okay. So some features which or some traffic which need to be processed. You know, anyone got disconnected?
No, I'm here.
All okay, right?
Yeah.
So now I'm talking about the medium path. So any packet, okay, uh, which need to be go with some sort of higher processing. When I talk about the higher processing, I'm talking about the say feature like IPS, application filtering, something like that. You know, for such traffic, that packets need to be go from the medium path. What do you mean by medium path? When we enable such blades, we enable such blade with respect to the core instances. So the feature of having IPS will be delivered the processing part from this instance only. Okay. So for example, this instance having the IPS functionality. So processing the packet via only the secure Excel SND will not help here. That packet need to be go to the this firewall kernel instance to process the IPS sort of things. The IPS sort of enforcement. For that such packets, it need to be take a path which we call medium path. Okay, so here the packet state which is captured by the SND will be not having the flexibility and the features which will having or which will get from the IPS. For example, say whatever the packet, like a three-way handshake packet. First packet comes here, pass these details, you know, but you never know the second packet, which is, or the third packet, which is also going to the firewall. It's not malicious, right? So having that packet processed by the SND only will not serve the purpose when the IPS things got enabled. For the malicious thing, you have to have that packet need to be processed by the IPS. It has to be go to the firewall control module, and from there that packet need to be processed. For that, we have the medium path. Any doubt here?
It has to go through extra inspection table, and that's why it's a medium path because of those new features.
Yes, because of the see, when we talk about IPS, your filtering, you know, that has to be have some sort of different understanding altogether, right? IPS having their signatures, their algorithms, right? What SND or security dispatcher do based on the the previous things like IP source aggregation, IP source protection port, and the sequence number. Based on that, it allows those packets. But do you think they do all this processing on that packets? If we talk about the IP sort of things, right? It has to be done from somewhere else, right? Because every packet come to your network, it has to be validated, right?
Mhm.
We can't trust that okay, one packet is state got captured, the second packet will not like a malicious one, right? Anything can be happen. For such sort of arrangement, we need to have this medium path. That's why this sort of complications are there. But I am sure I have made it easy for you guys. You never ever forget this thing now.
Ooh, that was very helpful.
How about you, Ruturaj?
Mm, yeah.
Huh? I mean, just let me know you heard about these terms the way I
Which one?
told you now.
Yeah,
So you were having the understanding on this thing.
yeah. Ajay, I heard, but it's now clear.
It's now clear. That's what I want to hear. So obviously, the clarity part was not there because I know how the rest of the things people thought about this thing. They don't know about the inside of this uh, operating system level. So I hope this is helpful for you guys, right? So I assume this doubts, these paths. This is what the secure Excel guys. Okay, there is nothing much into the secure Excel. It's clear now. Just let me know
Mhm.
yes, no,
Yes, yes.
alright. So now let's come to the slide how the people talks about this thing. Okay. So this is what this checkpoint site has given the details. The medium path PXL perform the checkpoint active streaming, CPAS and passive streaming layer PSL, processing required by so-called deep inspection, blades such as APCL, UR filtering and prevention. I'm sure reading this you will not get any clue, but now you have a clue why they talked about this. In other words, also the medium path they also call as a PXL. Okay, why they call it PXL? Like processing required at another level. Okay, so if you heard about the terms like PXL, PSL, it's all about your medium path. Just remember that, right? And the accelerated path, I just explained. Uh,
Hmm.
Firewall path, slow path, or they also call it like firewall to forwarding, P2F path. So they have a multiple terms for this thing. Okay, but remember whenever this terms comes, say XL is nothing but the accelerator part, PXL is nothing but the medium path, F2F is nothing but the firewall path or a slow path. Okay, if you like, you can capture this slide for your reference. Uh, there is nothing much here. This is what the path we have just explained, and some definitions are given here. We talked about the SND. Core Excel software architecture includes a secure network dispatcher. SND is responsible for processing the incoming traffic from the network interface, securely accelerating the packet, distributing the non-accelerated packet among the kernel instances. That is what we have learned. Multi-core acceleration also we have learned. Now it's all about the command part. So we have finished two big concepts. One is secure Excel and one is core Excel. Practicality we will see in a bit. But so far, any doubt, guys?
No, that was good.
Okay. So we can either do this thing. We can go ahead into the command line and run the command, or we can see the already captured packets with the details. How you want to do this? It's just a command what we run for this secure Excel, core Excel, you know.
I'm good with the capture.
Okay. So here we'll talk about the performance. But before that, let's just finish these concepts and we'll take a break and we'll jump back to the our the rest of the daemons. Okay. So major chunks we are covering today. So when we go to the CLI and when we run this command fw acceleration or accel status, this command, you know, you will see these things: acceleration status. So if your secure Excel is enabled, you will see on. If it's disabled, you will see off. Okay, and by default, it is disabled. You have to make it off on. So the command is like fw accel on. That's it. Once you run this command, it automatically get on, and your acceleration gets started. So once you make it on, so you will see what are the things get accelerated. Okay, so whatever the accounting is there is getting accelerated, netting is accelerated, cryptographical function accelerated, routing is accelerated, you know, whatever the things mentioned here, you will see from your command line considered those things got accelerated. I mean accelerated here, the SND will help to deliver the work related to all these things, you know, performing more features and more, you know, capabilities. And they also mention when I talk about the cryptography, they mention in cryptography what is get accelerated. So these are the things get accelerated with the cryptography features, what they have. It's just simple thing, you know. Then we have something called NAT template, drop template. For a drop template, we enable this sort of features when we have certain, you know, certain situation occurred in our environment. For example, we are under impression of the, you know, a DOS attack or DDoS attack. That time, what we do, we just enable this drop template, and drop template having its own functionality where based on its algorithm it look for the packet sequencing. So if it sees that, you know, the three-way handshake is not happening, all the sync packets are, you know, only hitting to your firewall with the different references, it just drop those packets. I have a separate video on this, you know, how the drop template works and everything. I will forward a link. Okay, just look into that because it's again a deep topic. So if you better watch that video, will be save our time here and will understood like what is a drop template like here. So it's just a feature which use when we are under impression of the DOS attacks or something like that. So one which we can use as a SAM rule, but the SAM rule has a limitation where you can allocate a certain subnet range or IP addresses, but just imagine you are getting hit from multiple subnets, multiple this thing. Putting those details into the SAM table is not that easy. So that time, this feature like a drop template is very helpful. Okay, any doubt?
Not bad.
So we have the video for the SAM table as well. Just browse my channel, you will have everything there. Now, next.
One more thing.
Yes, sir.
As you have mentioned earlier that there is IPS, then it will not. If there is some malicious thing, will
Mhm.
go. Then it will choose the IPS path, right? It will go with the IPS. It will not be
No, no, no,
select.
no, 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 not like that. If your IPS blade is enabled,
Mm-hmm.
so right now this is your firewall. No?
Mm-hmm.
The packets are hitting your firewall. No IPS. We don't know which thing is malicious, which thing is not. So SND will work. Will process all these packets. But if
Mm-hmm.
you have enabled IPS, right now, the one more that soft piece is added into your firewall code, which is IPS. So IPS, what IPS does, it does some sort of algorithms, do signature-based analysis, protocol-based anomalies, all those things. But that has to be done on each packet, right? So one packet will, deliver that work, will not serve the purpose. Subsequent packet also need to be processed that. What this secure Excel network dispatcher or the core Excel dispatcher does, this captures the state based on the first packet, right?
Mm-hmm.
What about the rest of the packets? So first packet is good. We are giving that store here, and sub packet will accept based on this. But how about if this packet having the malicious content?
Mm-hmm.
It will allow, right? If the IPS enable and this content is allowed, what is the use of this IPS? Because of that, it need to be go to the medium path. So one thing is that here matching also go to here for the IPS filtering and then to the next word. Clear or doubt?
Okay, then when can we do the drop tablets?
Drop templates are the things when we have say DOS attacks. So IPS will do the work related to the signatures. If it has some say SQL injection sort of thing, or say log4j sort of things, sort of whatever it is, not log4j, but say SQL injection, attach into that, or say TCP fragmentation attack, something like that. Those signatures will detect by the IPs, right?
Yeah.
But
So is
what?
that yeah,
Yeah, let me
go
just
ahead, go ahead.
explain
Yeah.
this.
Sure, sure, sure.
What
Yeah.
about the packets which are just hitting to your firewall? Okay, just hitting to your firewall. This is the sync packet. Okay, this packet just hitting to your firewall, and when the packet will go all the way to all these things, the state get captured, right? And the subsequent get allowed. But now just the packets are hitting to your firewall. These are the sync packet, right? All are the sync packet,
Yeah.
and it's coming from different sources. There is no subsequent packet, right? So in checkpoint wall, if you go more deeper, there is something they have a buffer, you know. for all the packet processing. So they keep this state for a certain amount of time into the buffering size, and once they think that okay, there's something not receiving at their end, then that buffer get released and get next package into the place, right? That is what they have. But for such sort of things, always hitting to the firewall, then having this buffer utilized for these things is also useless, right? So
Yeah.
we have the this phenomena called drop template, right? Based on the intelligence, like it's a patent from the checkpoint, they have some intelligence into that, and that intelligence says whenever the packet hit to the firewall, and because of whatever the intelligence they have, the algorithm they calculate that whether the packet which is hitting to the firewall, you know, is need to be processed by the drop template or not. Okay, and if that query or that packet fall under this algorithm what they have, then they get dropped. It will not process well. I mean, all this processing need not to be required, and the buffer size need not to be stored. Okay, if you ask me, tell me about that intelligence, I don't have that. At least forgive me on that. Tell me the what the question were you are having.
So does that mean that drop template just to prevent or from the attacks or something?
No,
Or
generally,
generally,
generally people enable this drop template. You never know when what will happen. And for the better performance, interruption of the packet. Generally, they enable drop template. But when you talk about the theoretical part and the understanding part in a checkpoint world, why they have introduced this feature is more of your protecting from this sort of things.
will that show all my drop packets?
Will that show? What do you mean by that?
Means whatever we are getting the drops
Hmm.
means rejected traffics.
Hmm.
Will that show in that template or it's a different? It will show in different.
Yeah, I don't think so. Cares about those logs, you know.
Mhm.
I
Mhm.
don't care about that because that is what we have the drop template to save the firewall processing. When we talk about the looking at the logs, so it has to be processed by the firewall, right? So that everything is get minimized. But I think I also not personally seen this thing, whether the packet is getting dropped, and we have seen that uh, not seeing those things into the uh, logs. Somehow we will get the evidence that okay, this packet is getting dropped by the drop template features, but provided based on their algorithms and intelligence, that is compressed what output we are getting, right?
Okay.
I have a separate video on this drop template. Okay, your query definitely get answer on that. Let me show you, because it's a, again I told you, right, altogether a different concept. uh, Let me just show you that thing where I have that detailed video, because this queries what we were just raising, right, is already got covered over there. And that time I was having those things in place. I have generated traffic based on such sort of things. Let me pause this video, and if you come here, let me search it. uh, Drop template by firewall. Hmm. So if you look this video,
Mhm.
Wix users aren't. You're on steady ground with Wix e-commerce.
So let's begin. What is so here I have almost covered, how you can implement, what are the things coming to the picture. Uh, I have run some, IPS signatures and everything. Just go ahead and look into this thing. You will come to the conclusion like how the process happens, how the things looked and if it is looked by the
Mhm.
logs, you know. It's not in my head now, so but this video will give you all the glimpse of it if so as I can see here, I can see that drop template is processing that thing.
Okay, I will check that video.
See,
If I
see,
need
see here.
anything, then I will ask you.
X. Yeah. Anyhow, the purpose was to show you how to implement the. Yeah, just look into that. You will get more understanding on the drop template part.
And what about NAT table, NAT templates?
NAT tables again, it keeps these details on the natting part. If you enable the NAT template, what are the processing happening with respect to the natting part? You know that is get accelerated. So when we configure the NAT in our environment, and
Hmm.
if we enable this template, the natting related processing, that is
Hmm.
also get accelerated. So
Okay. Other than that, if we don't enable that template, then how it goes?
if it not enable, of course, it will process by your uh, call dispatchers, you know. So it will not process by your SND. So it's
Hmm.
all about the SND, right? If we
Yeah.
talk about the secure Excel, it's all about the SND. So it depends where it need to be processed at the performance pack level, or you want to process at the kernel level. All these things work together. So enabling these features depends on where that packet will be processed. And of course, if we enable these features and process by the secure Excel performance pack
Mhm.
level, of course you have the benefit over there in terms
Okay.
of the processing, right? Okay. So next slide also talks about the same thing, which we have just discussed. This accelerator features, cryptographical features, what secure Excel capabilities we will get, out of this.
Mhm.
Now, it's just saying that, okay, if we are enabling the secure Excel is good or bad. Of course, depends, right? All the traffic which is, processed by the secure Excel, it's not something like that, whatever the traffic we have in real world, all traffic will be processed by the secure Excel. So why we need to have a core Excel also in place? There is a you might be having this question, for example, you know, this dispatcher which is from the uh, core Excel will be giving you the similar sort of effects like the SND, right? You might be having such sort of question. So why we will have dispatchers also and the SND also, right? Why we only have the dispatcher? Why this SND introduced? So of course SND deliver more better throughput than the dispatcher, but SND have a limitation in terms of the processing the traffic. So uh, for the traffic which we call like quality of service QoS, such sort of traffics, uh, I mean, when we look into the limitations, like what SND will not process, with what things SND will process, uh, we'll come to know about this. Let me look for that details if I have, so I will give you the better understanding. What things get not processed by the, yeah, yeah, right. So certain things which is not processed by the secure Excel that get processed by the core Excel, and certain things which is not processed by the core Excel uh, may be processed by the SND. I mean, these two technologies, they have designed in a such a way that they work together, you know, to have the desired output. When I talk about the limitations, core Excel does not support, for example, say quality of service. It does not support, the route-based VPN. Uh, it does not support the features like overlapping, natting, something like that. You know, so these features are not supported via core Excel. So you know having the core Excel enabled into your firewall and not supporting this feature is a drawback, right? So when we take a decision, when we want to open or we want to, uh, run the core Excel, our firewall make a completely core Excel base. At that time, you have to consider these things, which thing we need to be, our environment have which things is not in our environment. There has to be consideration. uh, you need to look into the limitations of the core Excel. If you just go ahead and search into the Google that what is the limitation for Excel, you will come to know uh, why uh, people not fully enable the core Excel into your environment. Similar goes to the secure Excel. So secure Excel also, as we know, it just accelerate your packet processing, but also there is a limitation like which packet is generally get more acceleration than the normal packets. As I said, when I talk about the IPS packets, this packet need to be go via their kernel module for in-depth processing. So likewise, there are some limitations. There are not a few, I mean, advantages having this platform in place, right? So this slide talk about the just assessment where we say what is good, what is bad, all about the secure Excel. So at this point, let me know if you have any queries, or we'll take a break and we'll come back and we'll jump back to the firewall demos.
Or let's take a break.
I know it's a little bit overhead because a lot of concepts are there. This technology is not limited to the single point. As you think more, as you ask more question, you will get into deeper into this part. Okay,
All right.
Okay, till what time we are going to be continue after that?
let's continue a little bit today because today is I think how about you, Ruturaj?
After that?
You are okay with having this session extended because now we are in a link, so it's
Mhm.
better to cover important topics, right?
Yeah.
The main purpose is you guys should understand. It's not like that I want to cover the concepts. I just want you guys to be linked together and having the concept with you guys, right? So what we'll do, we'll have next 1 hour. Is that fine?
Mhm.
Yeah, no
Uh,
problem.
we'll be
No problem.
covering the main things now, like the leftover from the previous class. So we'll be covering these daemons
Sure.
uh, and some important debugs I wanted to give you guys. And if you have a strength, then we will talk about the connection table and the packet inspection flow. If not, we'll take that tomorrow.
No, but
So
Damon's part we can take it to tomorrow because maybe it will be too much
No, no, it's a theoretical part.
to digest.
It's just a theoretical part. You just have to understand what is daemon, this thing, because we have a time left over, and I don't think so. We know how to troubleshoot this thing. We just wanted to know like how this thing work together. That's it. So what I will do, we'll cover the daemon part today, and the rest will take tomorrow. Daemon and this debug code. So today at least you will be having some practical stuff with you to do your labs. Okay,
sounds good.
Mm.
All right.
let's take a break for 5 minutes and come back.
Okay. All right. I'll see you.
Yeah.
Okay.
So I'm back, guys. How about you?
Yeah, I'm here.
Yeah.
Okay. So what we will cover, we'll just cover daemon part. Uh, I know you guys are exhausted, and the lab part we'll do tomorrow. So we have some more 15-20 minutes left. We'll cover the theoretical part of the daemons, right? Is that okay?
Yeah.
Okay. So when we talk about the daemons, we know the CPD daemon. Now let's talk about the FWM daemons. So FWM is a firewall management daemon. Is available on any management products. So if you buy any smart one or a multi-domain security management products, you know, which require your direct GUI access, uh, it has this FWM daemon in place. So the products like a smart event, uh, such sort of things, they were having this FWM, uh, the daemons availability. So you can consider the FWM. The example for it is smart event. You know the smart event, right? The feature of the checkpoint firewall, where we'll see the stuff like logs like IPS and your, application level logs, everything we can see from these IPS events, right? So the products like smart event, which we require a direct GUI access, will be having this availability of this daemon. Also, when we talk about the GUI client communication, the communication between the management server and the GUI client. So GUI client is nothing but your PC where you have the smart console installed and your management server. So that time also this daemon come into the picture, which is FWM. Then database manipulation. This includes all actions that are performed on the management things, such as object creation, policy package creations, inside the policy package rule creations, defining the users and such sort of things. So when we do deliver this sort of work, the FWM process or the daemons come into the picture. Then the policy compilation. So FWM handles the policy compilations that is, we later apply to the network traffic during the, the inspection process. Also the management HS sync. The sync management is handled by the management high availability as well as the, the features which we have into the clustering part. So all these features like GUI client communication, database manipulation, policy compilation, and management of the HA is handled by this daemon. Okay, so when we go to the lab or run this debug, we'll come to know how the thing works. So let's understand the rest of the daemon. It will not take much time, and we'll try to run lab because it's not a complicated. What we will do, we'll try to install the policy and we'll capture the output into the files and we'll see what other things come into the picture when we deliver such sort of things. Is that fine, guys? It will not
Sure.
take much time. So this is what the FWM daemon. I hope you don't have any query on this. If you have, let me know now.
No, we're good. So we're
Okay.
good.
Next. So next daemon is FWD, which we call firewall daemon as well. So MWT allows the other processes, including the kernel, to forward the logs to the external log servers as well as the management servers. So when we talk about the forwarding logs, that time this MWT process come into the picture. So we forward the logs to the external server. So you have a Splunk, Oxide, RSA Envision, say whatever the Symbologic, whatever the external servers you have where you forward the logs. That time this FWD process come into the picture as well as the simple log transferring take place from your gateway to the your management server. That time FWM process come into the picture. So consider tomorrow you are not seeing the logs reaching to your external servers or some happening or some issues on the logs, forwarding to your management server. You have to debug this process, which is called FWD. You have to see whether this FWD is running and it's having no issues on this. So it's related to the policy installation as well. Uh, so uh, it used to communicate with the kernel using command line tools such as the FWD commands. So when we install the policy, that time also this daemon come into the picture. Also, when we run the commands like fw ctl zdebug or say fw get ifs, when we run this sort of commands, that time also in the background, this fwd daemon come into the picture. Okay, so more of your command lining part, more of your policy installation related issues, more of your forwarding the logs, you have to consider FWD daemon. Okay. Any question on FWD?
So these are all user processes. User
Yes.
use and
So
run
whatever
from.
you do from your side, you put the details into the device. This thing will come into the picture.
This is on the management server.
Yeah. Now, FWSSD is a child process of the FWD, you know, which is responsible for maintaining the security servers. Uh, you know, when we invoke the blades like DLP, uh, you heard about the DLP, data loss prevention, you know. Also the endpoint connects thing. When you enable such sort of features, that time uh, the process invoked. I mean, this sort of processes get invoked like FWSSD. Okay, so it's a child process of the FWD, but provided the situation where it get enabled or it come into the picture when we enable such sort of blades in our environment. Okay,
Good.
right. The next one is CPWD. CPD, also known as a watchdog. So it's also a process that invokes and monitor critical processes such as checkpoint daemons. We run the command cpwd underscore admin list. You know, we see all these daemons, what is their status and everything. So that time this cpwd come into the picture. Uh, you know, last time we saw one problem, not a problem, one thing. We killed one process, right? We killed what? CPD.
Mm-hmm.
But after that, again it come up without doing anything. You know, why that happens? Because of this daemon.
Restart.
So it says restart attempts. So whenever we kill any sort of processes, okay, but not administratively killed, the way we did the second part, The first part we just use the command called kill, but somehow that process again gets established, right? We'll see that again, okay, that process got killed and again come up because of this cpw daemon. Clear that why that kill process come again, because of this cpw daemon,
Got it.
right? So processes monitored, as we know, cpd wwm cpd. So we use this tool, cpwd underscore admin space list, to see this thing how it works, right? So this is, guys, all daemons what we have to learn, you know. uh, any questions on daemon part? We'll quickly go ahead and check some labs with respect to that. Before that, any questions?
Well, as you said that, or yesterday also we saw that
Mm-hmm.
even after killing that process, it comes up after some time. So, is there any time, any duration between that? If we restart or if we kill, is there any time period to come up that
See,
process?
that is not important, the time duration, but do you see, after killing that process, our sick or the management thing should get broke up, right? Immediately,
Yeah, it was not good.
but it was not. So there was no impact. So that's why this CPWD demands, uh, useful here to keeping track of those processes and trying to restart that. And I don't think so. We have anything to measure the timings. But why you want to measure that time? What situation? Let me know that.
No, because if it is coming up automatically,
Mhm.
then I think just that maybe there should be something behind that.
Yeah, but the way should be different. That's what I said. Two things. One, you're killing any sort of processes, and one, you're making that process or a daemon administratively down. Okay, so
Yeah.
killing that process, that process will come up. Okay, but you have some intent that, okay, just make that daemon down for some time and do some work and come back again. I mean, make that daemon up again. So that time you have to follow the approach with respect to the, administratively making this down or up. So uh, it's not recommended or not mentioned anywhere into the checkpoint world that kill particular process to achieve something ever. They have a separate SKS given if you want to, stop something. You know, so best approach, do the administrative down if you want to deliver any work. So with that, you only have the flexibility and the control under your hand. Otherwise, based on the algorithm what we have with this daemons, it will act accordingly,
Okay.
right? So, what we will do, we'll try to run debug for the FWM. Okay. Same debug will be run for the rest of the processes. There is nothing. You will come to know now. Uh, if you like, we can, run debug for each and every process and observe the output. It's up to you guys how you want to proceed, or you want, uh, we can only run the debug for one of the process and continue for the next part.
We'll try it. You can run one and then we can try it and come back to you tomorrow.
The code what we are going to run is the same for all the processes. Only
Mhm.
thing is that you have to see where that file stays, and you know how we can find that. I
Find command.
explained some find command yesterday. If you don't know the location, what you need to do.
Find dash. Put
For
dash name.
example, if I want to find the file, so fwm.elg, I will use the command find like this name fwm.elg. So it will give you the location where the fw.elg file is, right? And if you go to that location, and you will see the file is located here, fwm.elg, right? Uh, Also, there is a shortcut for this. Let me go back to the root. So you can write this dollar sign. Where is the dollar sign? Okay. Dollar sign, like the CPDR we have done for the CPD. For this, we will do this. Sorry, I have to do ls. We will come to the same place, right? So what we're going to do, we'll try to install some policy into the gateway. Let me log into the gateway. So what we will do, we'll just create one policy. We'll say accept all for now. Just log that traffic. Have to publish it. And before that installation the policy, we'll try to run the debug. Okay. So now let's go ahead and run our old debug. So the syntax and everything is same. So first what we will do, we'll do like this, debug start here, and that will go to that fwm.elg file. Okay. Now we'll run the debug like this. Now debug is started. Not what we will do. We'll try to install the policy. Let's install into the gateway one. Okay, let's install the access policy for now. Install. So consider you have a situation where sometimes the policy installation get failed. Uh, you will getting some timeout error or something like that. You have to run the same debug. So I am just running for the sake of understanding. But any issue related to the policy installation, you have to run the same debug. You're getting my intention behind this debug. It's not only that we are just running the debug, we are running with respect to the daemons. Depends on what situation we need to run. So, based on the daemons, uh, the the daemons, the usability, what purpose it use. Based on that, you can run the daemon accordingly to solve your issues. So issue might be with the policy installation. You can go ahead with the FWM debug like that. So now we are just sending message that debug is stopped here. Alright. Let me clear up the screen. Let me see where I am. I'm here. If I say less fwm.elg, let's start observe that what we have given debug, something like that. So here debug starts. So we started the policy installation and these are the things took place. So much details there. Let's do this. Debug stop. Debug space stop. What we are given. Stop. let's do this. So are you guys following me or not? What I'm doing here? I'm sure not. What
No.
I'm trying to do, I'm trying to do see the status, right? Of course, these files are big and it will be having a lot of details. But what you need to do, you need to see if you will find something like status install failed, you know And beneath that, you have to see the details. If somehow the policy got failed, it will give you more details here that why that is got failed, what are the things not loaded or something like that. So this is based on your understanding, based on your in-depth search, how you can do. So if I say failed, I'll be getting the details related to the fail, like what are the things got failed. Uh, Let me start now. Why my PC is showing low battery? Oh, sorry guys. Yeah. So based on that, you need to see that stuff. So failed, successful, like that. So one thing you have to see this file when you run this debug. Second thing, also there's something called uh, messages file. So change to this, change to var log, and then there's something called messages file. Here also, if you see install something like that, you will see some detail related to policy installation. Right now it's this scroll down. Let's do this policy successful. So here successful. Installed. Policy. So based on what you are looking for, you have to filter on based on that. So if you're looking for something got failed, you have to go into that file and uh, search for those keywords fail and see what is there to what is got failed or what is got some issues. Depends like how what issues you are facing, you will be getting the output accordingly. Of course, it's all the kernel logs, so you require deeper attention and deeper understanding, and based on that, you have to do the troubleshooting. Uh, this is how usually we debug the kernels. Sorry, this firewall daemons, and we look into the things based on the keywords, based on the knowledge what we are getting output into the this file. So tomorrow you will see the policy installation fail, and it will give you some reason, say timeout or something like that. So you will go into that file and just search for the timeout. It will give you the more details like where the timeout happened and what are the processes not loaded after that, like that. Depending on the situational thing, you have to look into these files. But as I told you guys, the intention, the awareness, the troubleshooting steps, this is what you need to follow for debugging these daemons. Okay. There's nothing much fancy. It's based on your whatever knowledge you have. You have to do the troubleshooting, right? These are the important things which we will see tomorrow because I know you guys are already exhausted. So I'll be giving you this more detailed troubleshooting steps to uh, troubleshoot a particular issue. So I think this is the scenario based troubleshooting. Yeah. So we'll be giving that tomorrow, and then we'll be talking about the the kernel, how the packet get processed via the kernel. Uh, then the connection table formats and everything. We have covered the secure Excel, core Excel, and then after that we'll run some uh, this core Excel, secure Excel thing to see the stuffs, some important commands. And then after we'll go for the performance assessment, the commands. Then after that, everything is a more of your command line. How you can see the stuffs.
The
Using
SIM affinity and CPU affinity, right?
sorry.
We are going to
Mm-hmm.
check the SIM affinity and CPU affinity, right? That's practical.
Your voice was broken. Come again.
Are we going to check in a practical lab the SIM affinity?
Seeing which connectivity?
SIM affinity.
Uh,
SIM affinity and
Depends.
CPU.
I mean, that is more of your appliances base. We'll try to see if we can see those stuff with the command line how it look like. But if you want to assign those stuff, it's more of your appliance based. So if you have a multiple interfaces, with your checkpoint appliances, that time you can do that. But we'll learn command accordingly, the as per our requirement. So we'll do that as well. Sim affinity, CPU affinity, and all the
Yeah.
stuff. We'll try to do the assign the core processes using the cp config. We'll try to enable the core Excel, and we'll see how the CPU is getting allocated, how this AW worker process come into the picture, running some commands. Uh, yeah, so now I think after this, the theoretical part we will have is your management server HA and the VPN part. But rest of the things are more of your command line now. So looking into the real stuff.
Yeah.
Okay. Yeah. So just digest the thing. I know we have covered a lot of things today and good concepts as well. I hope that this session was informative for you guys.
Man, a lot of stuff.
I know. I mean, it's a, to be honest, the deeper you go, you will find a lot of things. Uh, there are a lot of concepts, a lot of things are there. but it's not possible to touch base on each and every single small concepts. Some concept you have to learn, understand based on the the big picture. So now what my role is to present you the big picture. You have to go inside that big picture and find out the small dots and connect them and work. But somehow I'm sure this sort of uh, overview analysis will help you for sure, whatever the scenario you will be facing in troubleshooting world. I know this sort of concept generally not covered into the trainings, but this is what the based on my experience, what I have learned on the checkpoint. So I try to cover as much as I can with respect to the concept what we have.
It's helping to understand the big picture.
Yeah. What we will do tomorrow will be doing a lot of labs, a lot of commands. I am going to give you a lot of important commands, and you will be surprised that okay, these commands are still exist, and based on that, we will do the analysis on this. So tomorrow is more of your command lining stuff. Uh, I hope we will get more on this. And day after tomorrow, then we'll start management HA. Uh, I think 1 day is enough for that, and then we'll start VPN thing, how to debug VPN sort of things. Uh, Also, I would give you some important things, which will really helpful to see the things in a different way, right? So, are we going at a good speed, right? There is nothing much which we are doing fast or skipping the concept here and there, right? Just give me the feedback so I'll consider accordingly that any improvement need to be have here.
Yeah.
Okay. Okay,
Just need
guys.
to
Yeah.
I just need to review all this topics. That's it. I mean,
Yeah.
there's valuable stuff in here.
Yeah. So what I will do, I have this recording. I will give you these recordings by